So we're going to start with the basics, and we're going to talk about network topologies in this video. Now, the topology, in a networking sense, is the physical or logical layout of the network. We make this distinction because the physical and logical topologies are not necessarily the same, so you can't always tell what the logical topology is from the physical layout. We'll get into that a little more in depth later in this video. But first, we're going to talk about the 4 common topologies you will see on local networks and wide area networks. They are the bus, ring, star, and mesh topologies, and the mesh is somewhat divided between the full and the partial mesh topologies. Now, each topology has its own advantages and disadvantages, and we'll go into each of these over the next few slides. The first topology we're going to talk about is the bus topology. The bus topology, on a physical level, is where every network device is connected to the same piece of wire. You have a bus that goes from one end of your network to the other, and each of these devices connect to this same physical piece of wire. Now, if we're talking about a physical bus topology, you may remember twin-ax, or you may remember thick Ethernet with vampire taps if you've been around quite a while. Although you won't see those in modern networks. However, you will see a logical bus topology if you happen across a token ring network. And again, it's been a long time since I've seen a token ring network personally, but I'm certain they're still out there, and they're far more common than the old thicknet networks. Now again, this is a physical topology that we're looking at. Now, you can have a logical bus topology and a physical star topology, and we'll talk about the star topology here in a couple of slides. And honestly, that's what most Ethernet networks are. They are logically a bus because all of the Ethernet computers are connected to the same physical piece of wire. But looking at the physical layer, they are a star because there's a hub or a switch in the middle of your Ethernet network, and all of the devices plug into that hub or switch. So the next topology we'll talk about is the ring topology. Now, I'll be honest, the only place I've ever actually seen a ring topology in use on a physical level is certain point-of-sale systems back in another life almost 20 years ago when I first started getting into technology. And essentially, the impulse goes from one end of the network to the other and just keeps going around and around and around this circle like so. Each device is connected to 2 other devices. The downside to this ring is if this link here is broken, then your whole network goes down because the traffic really only goes one way. Most ring topologies, at least on a physical level, will have counter-rotating rings, or they'll have dual rings. One ring goes this way, the other ring goes this way, and this way if one of the rings are broken, the traffic can still go the other direction to get to every node on the network. Again, a ring topology is not really anything you'll see on a physical level, but you will see them on a logical level, especially with metropolitan area networks or certain other wide area networking technologies. The third topology we're going to talk about is the star topology. And I mentioned this a little earlier when we talked about the bus, but the star topology means that every device is connected to a central point. This is the type of network that you'll find most frequently in use. Again, if you have an Ethernet network with switches or hubs in the middle of it, this is how it's going to be laid out. The advantage of this is that every device is separated from every other device by this cable. So if this one cable goes down, you only lose communications to this workstation or printer or server or so on and so forth. The downside to this type of network is if this switch in the middle goes down, everybody's down. Unlike with the ring topology, where you could have a ring going the opposite direction and still have network connectivity. And the last topology type we'll talk about is the mesh topology. Now, this particular image shows a full mesh topology where every node is connected to every other node. So any one of these links could go down and you could still get to any of the other nodes on the network. This node could go down and, well, I can get to this node because I'm directly connected to it. I don't have to go through anyone else to get to this. You generally only see mesh topology networks on wide area networks because you can imagine the cabling requirements that would be needed to have a full mesh topology on a local area network. Every one of your workstations in this simple network with just 6 nodes, every workstation has to have 5 network cards in it and 5 network cables going to each of the other nodes. It just gets to be really unwieldy. I've never seen this on a local area network. And again, it's only for frame relay networks. Now, I've mentioned this is a full mesh network. I don't have a graphic for a partial mesh, but a partial mesh is basically where every node is not connected to every other node. Let's say that this is a satellite office here. Well, it really only needs connectivity back to the corporate, whereas all of these other branches needs full access to everyone else. So this node here may not be fully meshed with all the rest of them. It may only have a connection back to the central office. And that's a partial mesh topology. Now, you remember way back at the beginning where I said you can't necessarily tell the logical layout from the physical layout. Well, let's take a look at that. For example, let's look at a full mesh frame relay network, which logically looks like this. Any node can get to any other node on the network without having to go through any site. You basically have a big frame relay switch here in the middle that's your provider. However, the physical layout of this network is a star topology because each branch or each one of these locations only has one path out to the frame relay network. But you don't necessarily have to go through this point to get there. You have a logical connection between these 2 points inside this full mesh network. And that's the most obvious example of physical and logical topologies being divergent. The longer you work on networking, the more you'll see physical and logical abstraction. And in fact, when we start talking about the OSI model, that physical and logical abstraction becomes even more pronounced at certain layers of the OSI model. And that concludes our discussion of network topologies.